This is one of a series of videos to explain the setup and operation of the WW9JD Arduino µMatic² memory keyer. I am Rick Dubbs, WW9JD. This is the construction video for the WW9JD Arduino µMatic² memory keyer. Using printed circuit board 1C. Now, 1C varied from 1D in a few ways. 1C added this row of holes so that you could make use of the power supply board that is supplied with the Nextion display. It increased the diameter of the holes on the µ2560 footprint. It increased the holes of the switch field and increased the hole size on each of the three stereo 1/8" jacks. The holes for the µ2560 were sub-sized to begin with. It was very difficult to stick pins in. There are some switches that needed a larger hole in this field, and the jacks themselves were difficult to insert in the 1B board and ended up at a slight angle, although not an angle that made it unusable. It made it unsatisfactory. So those were all increased in the 1C board. If you're building a 1B board, it'll go almost exactly the same, except for you can't use the Nextion power supply in a 1B board. If there is a 1D board, I may not change this video. It just may add a component or two, but we'll figure that out down the road. As a first step in the build process, it's probably not a bad idea to load the sketch into the µ2560. That's already been done. To check to be sure the sketch is properly loaded, one thing you can do would be to take some jumper wires that have pins on the one side and sockets on the other, and put those pins into holes D11 and D12, and then reset the board so it starts up. As it goes through its startup routine, it sends the K, the permission to send, that it normally does. You've not seen the rest of what's going on in the Nextion display because that's not hooked up right now, although that's also not difficult to attach. But that K sound indicates that that you've got the sketch loaded for the keyer, and you're good to go. There's nothing wrong with soldering all the pins on the µ2560 Pro embedded board, but I'm a little on the lazy side. I don't see the need to solder any more than is necessary. If you take a look at the fritzing diagram on the website, you'll see that this really only uses a few pins. The µ2560 has lots of pins to offer, but it was selected not for its pin count but for its memory capacity. The Nextion board uses lots of variables for the controls, and an Uno or a Nano just doesn't have the memory space that the 2560 does. So we don't need all the pins. What is on the diagram on the website and what you see shown right here on the board right now is all the pins that you need to have soldered. So I'm going to lay the board over the top of this, and then I'm going to solder all of these except for the pins right up here. I want to treat these a little differently, and I'll show you why later. But right now we can set the board on top and then start soldering pins from the top of the 2560. There are a lot of little pins on that board, so after you've completed the soldering operation, check carefully to make sure that each pin has been soldered. It looks like it's a good joint. It's not a cold joint, and there are no solder bridges. This is the micro USB breakout board that can be used as optional power for the keyer. And in foreshadowing those 4 pins I was talking about before, what I've done is I have taken the 4 pins that we're using, 5 pins, I'm sorry, that we're using to attach the breakout board, and I've moved them in the spacer so that when I place the pins through the holes and the board on the pins, I know focus isn't necessarily good right now, then those pins just come out on the other side of the board. Now the reason for that is the connection for the Nextion is going to be sitting in this area, and I want to keep everything as short as I possibly can. So I'll now solder that on the breakout board with very little extra leads sticking out the top. This is the area just underneath the µ2560 board, and there's really more space there. So with those long leads sticking through the board, I'll solder those and trim those leads. Now, before we can solder the µ2560 in place, we have one last bit of work to do on the top of the board underneath the µ2560, and that's the connector for the Nextion display board. So what you have is a single row 4 90-degree or right angle pins, but you want this as close to the board as it possibly can be, so you're going to remove that spacer. So leave the pins plugged in, but remove the spacer and insert the pins into the holes for that connector. Leave those connectors attached to the pins while you turn the board over and solder that there, so that there's sufficient space between the board and the pin to attach the connectors again later. Now I have one pin soldered on the field of the µ2560 to hold it in place, and I've made sure those pins are just sticking through the bottom of the board, and I'll solder them now. After you have the board installed, check all over for solder bridges and cold solder joints. One other design feature I'd like to point out is I have nipped away at this corner of this USB power breakout card so that the connector for the Nextion will better fit closer to the board and keep this distance between the back side of the PC board and the back side of the Nextion board as close as possible. Now, once we get one more component soldered on here, we can do some tests to see if everything seems to be soldered properly up to this point, and that's the piezo speaker. So insert it on the top of the board, solder on the bottom, clip the excess leads. The two initial power tests are both audio and visual. plug power into the µ2560 board, you'll see the LEDs start to flash. It's the sketch is going through its startup, and you get the K sound at 20 words a minute. The extra flashing there is really dealing with the micro SD card, which you have not yet installed. Be less flashing with that's installed. So to begin with, we're looking good. Let's try power in the optional micro µUSB breakout board. So I'm going to plug in power to that board, but that's not going to start things up because we haven't installed the switch yet. I'm going to just use a jumper between the connections where the switch is going to be, and just the pressure up against the plate through holes should apply power. There we go. Once again, you can see the LEDs flashing as it goes through its sequence, and we get the K. So we are good to go. Both of those. Turn the board over, and there's some other tests that you can conduct. While there's nothing particularly visible from this side, once you apply power to the µ2560, it will go through its startup sequence. There we go. And after we hear the K, then we can do some other tests. I'm going to take a single jumper, similar to what we used on the speaker before, plug it into the ground wire here on the Nextion connector. There we go. And as you can see right here, it says touch pin 2. That's the same as this. That is the straight key connection. So we're getting straight key tones here. This is giving us dits, the same connection that it will be used on the jack. Over here are DAs, the same connection that will be used on the jack. Down here are where's the pin is going to go. Pins are going to go for the external paddle that you attach to the board that you could also use on a KX3. Dits and DAs, all that's looking good. We can still do some more testing. While we still have much hardware to hook up, we can do some testing with the Nextion board. As you see, I've attached the one end of the Nextion cables to the board itself. I can plug the other end into the Nextion board, and it's going to power up. Now what you have here is its initial display software that the Nextion comes with on its own. Next, I'm going to load the software for the keyer. To load the Nextion software, you just have to have a micro SD card that has the software on it. Put it into the micro SD card reader on the Nextion display, and then disconnect and reconnect power. So I'll just disconnect the ground wire to shut down the Nextion display, reconnect the ground wire, and it's going to search its SD card to find the software. It's found it, it's loading. And it says its update is successed. So that means that it updated the software. It should display the keyer when we disconnect power again, remove the micro SD card from the Nextion display, and reconnect power. Board just yet. A tap here brings us up to the main page, and we'll continue adding components to bring this closer to completion. While I don't have a particular preference for any individual micro SD card breakout board, these are 3 of the boards that I have used. They've all worked the same for me, but you can see here this board has 6 pins and the header's already attached. This board has 7 pins and you have to attach the header, which I already have. And this board has 8 pins and you have to attach the header, which I have not yet. I'm going to be using this board in this construction, and I'm going to straighten these pins so they come straight out. That's why this board looks like it's mounted upside down. Now you want to have this card mounted so the edge pretty much lines up with the edge of the printed circuit board. While there's nothing that would stop you from having this come hanging out, if it's inside the edge too much, you're going to have a hard time inserting and removing the micro SD card. Now your next task is going to be mounting jumpers so that you can get these 6 holes connected to the 6 necessary pins on this board or any other. Those are the only 6 pins you need on any board. And it's best if they're not crossing over each other here on this field. So what I tend to do is start here with ground and I put it to whichever hole I need, and then the 5 volts to whichever hole I need here, and this to whichever hole I need there, and so forth, so they're not crossing over each other. Let me show you. So here are the jumpers in what I believe are the correct positions, but I haven't soldered them yet. I've bent the ends so they're making contact with the plate through holes, but they're not soldered. I'll place the board in its holes, and it will be able to hold it back so that it makes contact with its holes, and then there's a test we can do to see if everything has been wired up right, if everything's making contact. On the back of the board, you're given the instruction to tap pin 35 to ground to test the micro SD card. While this is on the back of the board, it's easier to see the LEDs and everything if you do it from the front of the board. So what we'll do is take that jumper that we have used before and attach it once again to the ground pin, because that just makes it nice and easy. Then flip the board so that we can see the front of it. There we go. If you have a micro SD card board that you can actually install upright, then you'll be able to see any LEDs on that. Supply power to the µ2560 so that it starts the initialization routine. With the initialization routine complete, I'll now take that jumper and just touch. All you need to do is touch once, pin 35. And that's what it sounds like if you have the wires in the proper jumper spaces and everything's making contact. It's entirely possible, though, that you could have an error condition and everything won't be making contact. Also with this process, an SD test file is written to the micro SD card that you can take a look at. So what does a test failure sound like? I've taken a bit of foam that I was using to angle the board and make sure it was making contact out. So now I'll touch pin 35 again. Those warble sounds are bad. That means you've had a failure. Really good chance it's just something that's not making contact. So check your contacts and try the test again. I had some problems when I put this in initially, and I had to get out the meter and test continuity. And I tested continuity all the way back from the pins that are supplying these signals to the pins on the board that are receiving the signals, and found that one of my two over here was not making good contact, and I fixed that and got a good test. With that test passed, I'm now going to solder the jumpers and solder in the micro SD card breakout board. Now, with all the jumpers and the board soldered, and before I clip leads, I'll run that test one more time to make sure that everything is hooked up correctly. SKQSLK, we're good to go. Now I'm pretty much just going to stuff this board from bottom to top. Put in the 4 right angle header assembly here to attach the KX3 style keyer. Drop in the 2 opto isolators and then the 3 jacks. I'll come back before I install the switch, which will be the last thing I'll do. If you are installing the optional power switch, there are a number of switches you can use. That's why I created the field there to allow for a lot of installation opportunities. The switch that I'm using, I've detailed in the printed instructions how to attach a couple of header pins to be able to drop this into this field. There are also switches that already are designed to be installed in a right angle fashion on a printed circuit board. But I want to have more mechanical connection to this switch than just those 2 pins to hold that securely, because this switch is going to get used a lot if you're going to put it in. Now, to attach this switch more firmly to the board, and instead of just the soldered pins, I use a product called QuickWood. It says it's a wood repair epoxy putty. Rebuilds anything made of wood, but as an epoxy product it will happily glue essentially any 2 things together that aren't wet. So what I'm going to do is take a very little bit of this. This is parts A and B together. You just pinch some off, you knead it until it's a uniform color, and then I'll make a very tiny little ball, put it on the board, put the switch down on top of it, and then in about an hour that will cure. I'll likely solder it before the hour starts, but you could certainly wait until after. And that's all the bigger piece of QuickWood I'm going to be using here. That's probably too much. Then I will drop the switch on, putting the pins into their proper holes, and then push down to make physical contact with the board. Keeping it away from the toggle, but getting it down as good as I can. Push some up there onto the threaded section of the switch. Now that will hold the switch very, very well in place. It's not going to go anywhere. And then I'll solder the back side and let that cure for an hour. Now I needed to pinch off enough of the quick wood to be able to be sure that I got the two parts equally mixed. There's plenty of quick wood enough there to put the standoffs on to attach the iambic key on the end if you want to do that at this time. I'm not ready to, so I'm not going to do that right now. As far as the iambic key attachment goes, I'm going to make a separate video on that later because it can be attached later, and I'm not ready to do that just yet. But need to finish up and put all this together. We have one operation to do on the back of the Nextion display itself. Now the Nextion display comes with this attachment harness, and you could, I haven't completely plugged that into the socket. You could plug that in and bring these wires around and plug them into the underneath portion of the keyer board, and these two things are going to end up going back to back like that. If you space these apart, there's plenty of room to wind that around there, but I don't like those wires sticking out like that. So what I have done in the past, and what I'll do now, is I'm actually going to cut these wires short and solder them onto the back of this connector, and then there'll be very little wire left needed to coil up to then plug that into the pins that are prepared on the back of the keyer board. So I'm going to cut and prepare those wires and the socket right now for that. In the past, I've cut those wires fairly short, about this length right here, so that they just make it onto the pins. But I've decided that it's kind of difficult to make my attachments that way. I'm going to go ahead and cut the wires to about this long, put a single coil loop in each wire. I'm thinking that's going to work out just a bit better and not going to take much more space. So that's how I'll prep these wires this time. So now I've cut the wires from the harness, strip the ends. Now I'm going to tin the wires and tin these portions of each connector, each pin on the connector. So I'll have both the wire and the connector tinned, ready for soldering. So now I have the wires tacked on to that connector. The only stress they're going to see is when I put this together, since I don't intend to take it apart again. As long as I'm careful, I put it together, then those wires should stay put, and the device should operate for a long time. The last thing I'm going to do before I put things together is insert the 1220 battery into the holder for the real-time clock. The real-time clock needs this battery so that it will maintain time in between you having it powered up. And I'm going to turn these two boards towards each other and start the assembly process. Okay, and there it is together. You can see the wires kind of coiled up in there. And as I was assembling this, I've decided that the next one I build, and if I make a change to the board, which I probably will, the next time I change the board, what I'm going to do is reposition focus. There we go. Reposition these guys so they are facing the other direction. I may move them too, so I just flop this whole thing. That way I won't have to have that coil of wire there. The wires will come straight out the back of the connector and do just a single turnaround and plug into those pins that way. There'll be less stress on those wires there and make it easier to put things together. So you can see we have a short spacer and a longer spacer. Now the screw has a little bit of thread sticking out the end, and I make use of this. My installation of the keyer is at an angle, and so I have it. Some holes drilled in the wood that I use to support my my KX3 pan adapter, PX3, at an angle. I have this right beside it, and those holes, then the screws fit right in there. Now there is no screw here. What I will do later is take a nut and glue that on there so that I have so that it doesn't wobble when I'm sending it down flat. I also have no screw in here. It's not really needed, and the screws that I have are too long, so I may cut one off, or I may try to find a shorter screw to put in that hole, but it's not needed for mechanical reasons or anything. So let's go ahead, plug in some power. There we go, power connector. And then for the very first time, turn this on. Up it comes, and it asks you to put in your call sign. Please understand that when you put in your call sign, you can change that at any time. It's just asking for that first so that you'll have it. But it's not a permanent thing. You can change call sign at any time you want, using the same process for that matter. And I have other videos on initial setup, so that concludes construction.